rows and columns that's great for organizing data. Think about spreadsheets. Spreadsheets mathematically are coming from matrices. So like you do different things to the different cells of a spreadsheet. It started from like a mathematical matrix. That was the original math behind it. A matrix is named using a capital letter. So down here, this is matrix G. The element of a matrix is just an item in a matrix. You use a lowercase letter and then a subscript of row, comma, column. So I'm going to show you what that means below. And the dimensions of a matrix are always rows by columns. And a hint to remember this is railroad crossing. See how there's like the time symbol crossing? Railroad crossing, rows, columns, RC. So if I wanted to tell you the dimensions of this matrix, rows are always horizontal. So I actually have 3 rows, right? See, 1, 2, 3, 3 rows. Columns are vertical. So 1, 2, this has 2 columns. So in the classroom, I feel like sometimes we confuse you because would you consider yourself sitting in Aiden's row or Aiden's column? Technically, Sammy and Grace, you guys are in Aiden's column, and then this is the front row of the classroom. Is that what you would normally think of? Oh, okay. So okay, so you got that. Yeah, the columns on a building outside, like the middle school has those white columns. That's vertical. Okay. So, I mean, think about even just a seating chart. You could use a matrix to represent a seating chart, and then whoever is in element 1, 3, they'd be at that desk right there. First row, third desk in, right? So I could designate Aiden as 1, 2, just like a coordinate. It's like a coordinate. So the name of this example matrix is matrix G. How many rows are there? There are 3 horizontal rows and 2 vertical columns. So the dimensions of this matrix, it's called a 3 by 2 matrix, which would look very different than a 2 by 3 matrix, right? A 2 by 3 matrix would have 2 rows and 3 columns. So a 2 by 3 matrix is different than a 3 by 2 matrix, just for terminology. What is number G 1, 2? So that tells you go up to matrix G. It's one of the elements. Row 1, column 2. So the number is 5. So it's a way of quickly identifying one of the elements in a matrix. And then how could you name 0 up here as an element? So that one would be lowercase g. And then what would I use? Subscript row 3, column 2. So G 3, 2. So it's just kind of this new mathematical world. You haven't heard about some of these words before. Rows and columns and organizing data this way is a little bit new. All right, so here are 3 matrices that they've given you. And I'd like you to try to state the dimension of each one and determine what element is in each position. And if the element doesn't exist, you could just write undefined, because not all the elements might be correct. Are you with me on that? So take a minute on your own to think about these examples. Go with the 2 questions below it, basically. My video, I'm going to talk. So A should have been 3 rows, but 1 column, so 3 by 1. B was 2 rows, 4 columns, 2 by 4. And then 3 rows, 2 columns, so 3 by 2. And then row 2, column 1 is 4. Row 1, column 4 is -2. And then this one was row 3, column 1, -7. And I just wrote the question, is there a C1, 3? So there's no column 3, so like you couldn't write that element, right? So if I ask you, what is C1, 3? You could just say that's undefined. It's not part of the matrix. But it wouldn't be 0 because 0 is a number, right? Yeah, NA, or you could write like empty set, like the 0 with a slash through it, empty set. There's nothing in that position. So don't be afraid that, oh, it doesn't exist, I must be doing something wrong. I want to know that you know the difference between 3 comma 1 and 1 comma 3 as a position in a matrix. It's always, just always go back to that hint, railroad crossing, rows then columns, railroad crossing. All right, so then you can actually do something called a matrix operation, and that's just adding, subtracting, or multiplying a matrix. And so here I wanted you to just basically learn how to add and subtract matrices. So if you take matrix A and you take matrix D, it says write them out and then add or subtract them. I don't know if you need to spend the time to write them out. If you basically add the like positions, so I'm going to add 1 plus 5, and I'm going to get 6 in the top position. And then I'm going to take -3 and add -2. So that would be -5 in the middle. And then 0 plus 1 is 1. All right. And B and E you're going to add together. So you're just going to, it's going to be the same shape that you started with. And then you're just going to add the like positions together. And then you're going to take C and subtract F. All right. So could you try to add those together and see what you get for each one? It has to be the same size to add it together. So one of these ends up being that you can't do it. So only add them together if they're the same dimensions. Right. So which one is the one that you can't do? Right. E plus C, we would just say is undefined, because what would I add to each element? I'm not sure. It has to be, there has to be a corresponding, like, you know that 9 plus 3 is going to give you 12 in that spot, no question. Right? It has to be corresponding. What you got? 12, 3, -7, 3, and then 5, -3, 10, 5. Does that sound right? And then, yeah, 1 and 4 were exactly the same. And 3 and 6 should be exactly opposite each other, because when you subtract them in the opposite order, the minus and plus signs are going to get flipped. So 2, -2, 4, 8, and then -8, 1. And then you make them all the opposite in the other one. Because like when you subtract a negative, it becomes positive.
Right. The only thing I didn't think is, oh, those are zeros, so it won't change it.
Oh, because the position, yeah. So that's called the commutative property. When it's the same forward and backward, like 1 plus 5 or 5 plus 1 is always 6. But if you did 1 minus 5 or 5 minus 1, that's not commutative. So addition is commutative, same forwards as backwards, but subtraction is not commutative. And they need to be the same size matrix, right? So that's adding, subtracting, and then I forget. On the next page, do I put multiplying? Are you good on this page?
Yeah.
Okay, multiplying. So there's 2 different types of multiplication. The first is just called scalar multiplication, which is easier. It's like the distributive property. The second is when you're actually taking 2 different matrices and multiplying them together. It's not what you'd think. It's not like multiplying the top one times the top one and the middle one times the middle one. Matrix multiplication we're saving as an operation because it's a whole set of rules that you have to do. Scalar multiplication is just the distributive property. Question?
Is there a difference? Okay, so I guess this is just like,
Oops, I forgot to unpause, but scalar multiplication is you're just distributing inside the matrix. So 3 times A, you do 3 times 1 is 3, 3 times -3 is -9, and 3 times 0 is 0. And then I told them that if they take 0 times a matrix you're going to get a 0 matrix that's the same size as the original, and you can't just write the number 0. So now they're trying 2, 3, and 6 on their own. All right, so we did okay on scalar multiplication, right? Not too hard. It's just organizing your thoughts on this stuff. So we did okay on those. Do we need to check any of them, or do I need to say them out loud? We're good, we think. Multiplying by half, multiplying by 4. So the last part that I wanted you to just kind of try on your own for the last 5 minutes, or maybe you could finish it if you don't have time to finish it right now, but it's only 6 problems. Either add or subtract the matrices or multiply them by the scalar. So you're doing a combination of things. And then 11 and 12, you're thinking about, like, what does X have to be to make the statement true? So you just want to look in those specific positions, or like, what does Y have to be to make the black circles true at the bottom? You know, so follow through what the variable's doing. And it just says, if you're going to distribute, do 2A first. So you might want to write down, like, what is 2A, and then I'm subtracting off D at the end. So, like, there's my matrix D, and then what is 2 times A? I want to do that first. So 2, negative 6, 0. Now I can take this matrix and subtract this matrix. So don't forget, like, order of operations, you want to do multiplication before you do the subtraction. So take 5 minutes and see if you can finish those last 5 problems, and I'll either put the answer key up at the end of today or beginning of next class.